Welcome to Get Your FRQ On. This question is from 2017. It's question 1, and it is calculator active. In the question stem, we have a tank for holding liquid, and we have various values for the cross-sectional area of the tank at different values of height. In part A of the question, we are asked to use a left Riemann sum and 3 subintervals to approximate the volume of this tank and to provide units. So using the data from the table, the volume would be the integral from 0 to 10 of our area function a of h dh. And using the data from the table, we get 2 times 50.3 plus 3 times 14.4 plus 5 times 6.5. This is a calculator active question, so you can let your calculator do the work here. The volume that we would get here is 176.3 cubic feet. In part B, we are asked if our approximation from part A is an over or underestimate and to explain why. So we're given in the question stem that a of h decreases as h increases, which means that any Riemann sum we use using our left-hand Riemann sum will include area that is not meant to be included, and therefore the area we get will be more than the actual area. So this will overestimate the actual volume of the tank because a of h is decreasing. In part C, we are told that horizontal cross-sections at any given height h have area f of h equals 50.3 divided by e to the 0.2 h plus h, and we are asked to find the actual volume of the tank with units. So the volume of the tank can be found using an integral because we actually have a function for the cross-sectional area at any height h. So the volume would be the integral from 0 to 10 of our f of h function, 50.3 over e to the 0.2 h plus h dh. Since this is a calculator active question, we're going to let our calculator evaluate this integral. It does not look fun to do by hand. So the actual volume of this tank would be 101.325 cubic feet. In part D of the question, when h is 5, dh dt is 0.26, and we are asked to use the model from C to find dv dt and to provide the units. So according to the model from C, the volume at any given height h would be the integral from 0 to h of f of x dx, which would be the integral from 0 to h of 50.3 over e to the 0.2 x plus x dx. So if we apply the chain rule here, dv dt would have to equal dv dh times dh dt. And according to the fundamental theorem of calculus, dv dh is just f of h. So we get dv dt is equal to f of h dh dt. So dv dt at the instant when h is 5 is just going to be f of 5 times dh dt when h is 5. Substituting in the values that we know, f of 5 is in the table, and dh dt, we are given when h is 5, dh dt at that instant is 0.26, so if we multiply those two values together, we get 1.694 cubic feet per minute.